Welcome to part 2 of this week's video lecture. In this segment, we take a little bit closer look at the spinal cord and spinal nerves. So for this exercise now, we are on page 301 together. And actually, let's start on page 302. So let me bring this down to page 302. Here we go, I think. This just doesn't want to turn the page today. All right, there we go. So the first thing we take a look at is the anatomy of the spinal cord. And this, again, is going to have pretty important clinical significance that I'll talk about in a moment. But let's just talk about an overview of the anatomy of the spinal cord. So here you are actually seeing the spinal cord. And it extends from the foramen magnum, which is a very large foramen in the base of the cranium, all the way down to about L2, or the first or second lumbar vertebrae. And remember, we refer to that lumbar L, and so the first or second lumbar vertebrae, L1, L2. So that is actually the spinal cord proper. So the spinal cord does not actually extend the full length of the vertebral column. So that's an interesting first fact. At the very end of the spinal cord, as it explains up here, the spinal cord terminates in a cone-shaped structure called the conus medullaris. So the very end of the spinal cord proper is called the conus medullaris. Again, like we saw in the brain, the spinal cord has 3 meningeal coverings that actually extend from the brain down the spinal cord. And they are the dura mater, arachnoid mater, and pia mater. Again, if we're going superficial to deep, the most superficial and toughest layer is the dura mater. The middle layer is the arachnoid mater. Remember arachnophobia. This middle layer looks very spider-like, spider web-like. And then the very delicate pia mater, the very delicate pia mater that sits right up against the spinal cord itself. So remember, DAP, D-A-P, superficial to deep. We still have that subarachnoid space that, as its name suggests, sits underneath this arachnoid mater. And this is where our cerebral spinal fluid is found. So recall that from the brain structure. And then at the very end of the conus medullaris, we see extensions, branches off of that conus medullaris, and they are called the cauda equina. Those extensions look much like a horse's tail, and that's actually what the name means. Cauda equina means horse's tail. And lastly, we see a fibrous extension of the conus medullaris. It's covered by the pia mater, and it's called the filum terminale. And obviously, so that the spinal cord doesn't roll back on itself, that filum terminale ends up helping to anchor everything in place. And I should mention that those meningeal coverings that I mentioned before, the dura mater, arachnoid mater, pia mater, actually do extend all the way to the end of the spinal column. So here I want to make 2 important points. First of all, that the spinal cord proper ends at L1, L2, and after that we have extensions that branch off of that conus medullaris. The spinal cord is part of the central nervous system along with the brain, and any injury that occurs to the brain or the spinal cord proper, that is not, the body does not have any capability of healing or regenerating that injury. However, these extensions, known as the cauda equina, that sit below that conus medullaris, these are part of the peripheral nervous system. And they do have, if there's any kind of injury here, they do have the potential to heal. Okay, so these are part of the peripheral nervous system. That's really important in the next thing that we're going to talk about, and kind of like why we care about all of this, which I'll get to in a moment. So at this point in time, they mention a procedure, and actually we'll go into it right now, called a lumbar puncture. And the lumbar puncture is usually performed below L3. And the main reason that it's done below L3 is because, again, that point that I just mentioned, where if they perform that lumbar puncture above L3, they are in danger of nicking the spinal cord and causing a spinal cord injury, which would be really bad. So a lumbar puncture is a procedure that they go in below L3 so that they can, first of all, there's a lot of space here that you can see if I make it bigger here. There's a lot of space. We have those meningeal layers, the subarachnoid space that they can draw cerebral spinal fluid out of. And if they suspect any kind of bacterial or viral infection, they draw fluid out and they can run tests on that cerebral spinal fluid as a diagnostic. And so actually, if you go, and I'm going to actually have you pause our time together, go into, at this point, go into Canvas, put the video on pause, and go check out this video on lumbar punctures. And then we'll come back again together in a moment. So hopefully you had a chance to check out that video link on lumbar puncture. Again, a very valuable diagnostic tool. So let's go back to our e-text. You have a handle on the layout of the spinal cord. There are a total of 31 pairs of spinal nerves. So you can see, if you look at the spinal cord, we have in our cervical region a total of 8 pairs of spinal nerves that branch off to the left and to the right. So we have some branches going left, some branches going right. The right branches serve the right side of our body, and the left branches serve the left side. We have a total of 12 pair of thoracic nerves. We have 5 pair of lumbar nerves, 5 pair of sacral nerves, and 1 coccygeal nerve. So again, total of 31 pair. I do want to come back to this picture, and here you're just seeing a transverse section of the spinal cord itself, and I'll enlarge it just a little bit. So we talked about the meningeal layers. Here you're actually seeing a spinal nerve. So again, cervical 8 pair, thoracic 12, lumbar 5, and here you're seeing one of those spinal nerves. Each spinal nerve is mixed. It contains a mixture of motor and sensory information, and we'll talk more about that in a moment. But you'll notice that each spinal nerve have 2 branches that you see. You see a ventral ramus, and then you see this branch over here. This is known as the dorsal ramus. So these branches, the dorsal ramus actually supplies the posterior aspect of the body. Remember, we have our spinous process, and that is what tells you that this is posterior. So if you take your hands and you put it on your back and you feel the little bumps on your spinal column, your vertebral column, you're actually feeling those spinous processes. So we know that this is posterior, and that this big chunky body of the vertebrae, that sits more anterior in the body toward the belly. So we have these two branches, the ventral ramus and dorsal ramus. The dorsal ramus carries information from the spinal cord to the backside of the body, and the ventral ramus takes care of or serves the anterior portion of the body, which makes a lot of sense. We see those two rami come together in the spinal nerve. And then what you see, and we'll talk about this more in a moment, is that we see these branches. We see that spinal nerve split. So let me bring this in a little closer. Think about a restaurant, working in a restaurant. If you've ever seen the folks working in a restaurant, they have a door that goes into the kitchen and a door that comes out of the kitchen so that people don't bump into each other. Well, it's similar in the spinal cord. So we have a spinal nerve and it splits. It has one branch that comes in the back door, and then you see another branch coming out of the front door. Well, this branch that's kind of coming around more posterior, that is the dorsal root, and it brings information, only sensory information, into the back of the spinal cord. And this is the ventral root, and this only carries motor information. So the sensory information comes in the back, the motor information leaves out the front. We call this pathway an afferent pathway because it's going toward the spinal cord. And this pathway is the efferent or exit, and it's carrying motor information away from the spinal cord. How I keep that straight is I think of Nintendo DS. So I remember that dorsal is always sensory, and then ventral is motor. So again, we have our dorsal rami, ventral rami, or ramus, singular, coming into the spinal nerve, which is a mix of sensory and motor. That spinal nerve has branches. This guy carries sensory into the spinal cord. This guy carries motor away. And then, as I said before, we have our meninges, and I think that does a pretty good job of kind of looking at that cross section of just the basic cross section of the spinal cord. We'll get into a little more detail in a moment. At this point, you can take some time to just review that. Make sure you have a good handle on that. And let me go down a little bit. Make sure I covered everything. The next picture that we talk about is on page 304, but I think we'll start the next video segment off with this particular picture. So at this point, let me see if I have anything for you to take a look at. I think if you take a look at the video that is labeled spina bifida repair. So this spina bifida, first of all, why don't you look up what spina bifida is? And then take a look at this spina bifida repair video. Okay, so that gives you two assignments for this video. Look up the word spina bifida, find out what that is, and then take a look at the spina bifida repair video. Both of these are associated with the spinal column, or excuse me, the spinal cord. So take a look at those two and meet me back for segment 3